We as Gerrit Forge, and we are based in London, and we work not just on Gerrit, but we work on Jenkins as well. So we say, why don't we use our skills to serve the Gerrit project itself? Because we were running a few years ago where we didn't have an official CI, so we say, okay, we'll do it for the Gerrit community, that's fine, okay? So first of all, this is Gerrit CI, gerritforge.com. As I like live things, let's have a look if it's still up. That's the Gerrit CI. As you can see, it's busy because we have been running hackathon for a couple of days. And even now, even if the people out there, they seems to following, like Edwin, in reality is reviewing and making changes to Gerrit. Yeah, that's it. And the CI is watching you. And as you can see, we got lots of slaves. Some of them are even provided for free by Google, so thank you. Okay, so we're running this service, and that has been quite good, I would say, for the last couple of years. And some of you guys, they're using it as well for downloading some of the Gerrit useful stuff, such as the Gerrit plugins, or even if you want to demo the latest and greatest of Gerrit Master that we just did before lunch. So how it works. So first of all, you can log in with your GitHub account. Then it's me. And once you're logged in, you can trigger builds. And there is a useful job that is called Gerrit Verifier Change. So this job is very important because it's the one that is verifying every single change we make on Gerrit Review. How can you trigger manually a change in Gerrit? It's very simple. You go here, you put your change number, it will trigger your change in Gerrit. That is very, very simple. So what it does is has a workflow associated that is being developed in Groovy. And this workflow will provide a feedback to Gerrit itself by saying that this change is working or maybe it's not working. So when you go to Gerrit Review, if you go to the open changes, you will see that some of them have been verified by one guy that is called Gerrit CI. Yeah, that's the guy we have seen before, okay? So far, so good, but then at a certain point, the people in the community started saying, listen, Houston, we have a problem. I say, okay, what's the problem? We are too productive. We are producing so many changes and so many patch sets that the time that you just finished to build your change, you already built maybe another 300 changes. And why is my change gone? So let's review exactly how the workflow that we invented works, because this workflow does not rely on the Gerrit Trigger plugin. That is the out-of-the-box implementation that most of the people do. It relies on a completely new thing that we built because we need it. Because we couldn't use the Gerrit Trigger plugin, because the Google data centers, they don't allow SSH. And actually, the SSH channels, they are not fast enough for us. They will always be stuck with our changes, right? So the way that works is very simple. So whenever a contributor in Gerrit is pushing a patch, that could be a new change or a patch to an existing change, triggers the verifier flow. The verifier flow is just one guy that say, hold on, what I need to do now? And this guy actually go and scan the changes that are in Gerrit using the Gerrit indexing capabilities. So Gerrit has a very powerful query language that we haven't called it Gerrit query language, but is a kind of custom to Gerrit. This is basically a subset of Lucene. So you can use any field in Gerrit to query the Lucene index in Gerrit. And Gerrit can tell you a lot of funny stuff, such as, for instance, what are the latest changes that I need to verify since the last time I made a specific request. So, and based on these requests, triggers a lot of parallel activity. So if it sees that there are 5, 6, 10, 15, 20, 30 changes to be built, they will trigger parallel builds. And here is the limiter. The only limit is how many machine, how one can allocate for me. If you can allocate 100, we can do 100 of parallel changes, yeah. So far, so good. It means we can do a lot. And then whatever we do, for every single change, we don't do one build, because one build is not enough, because we've got the NodeDB build, we got the ReviewDB build, then we decided that we want to do some specific build to check if the syntax of the code and the consistency of the indenting is good and so on. And there was a moment that I remember that every single change was running something like 6 or 7 parallel builds. That results in a lot of builds. And as long as you got enough horsepower in the slave is fine. And whenever we get a feedback, we don't give a feedback for every single build. But we have the verifier change that coordinates the workflow and makes a decision. If you got a certain number of builds, they failed, but some of them they didn't, maybe we'll do some retry as well. And at the end of the day, we'll submit the feedback back to Gerrit. That is the one we have seen before, when we're saying Gerrit CI verified, yes or no. I will show you another verified flag that we use. Here, if you notice, let's go back to the browser. We have as well this code style, because this is a completely different job. So in Gerrit, we have a lot of different verifications. And even the verified is a multiple verification feedback, because it doesn't contain just the verification of a build, but consolidates the verification of more than one build. So in this case, this was a stable branch, so it contains just this one, basic polygerrit. Was a GUI change. So if you see, this is not the result of a single verification. But what we do is basically to trigger multiple builds, and you've got this coordinator that gets all the builds together and collect all the results and give you a single message in Gerrit that says, listen, this change is okay because I triggered 2 builds and both builds are successful. And that's good because you can limit the noise of every single change, because before we had a lot of different verification, the people were still merging the changes where they were not actually verified in other configuration and so on. Okay, that's the Gerrit CI, how it works now. So you would say, okay, so why are you talking about that? Yeah, because we had one problem, Houston, as I said, that we are too productive. So I will give you some numbers of our productivity. 300 jobs, 170,000 builds, 4.8 millions of jar artifacts produced, and 1.7 billion lines of logs. And of course, we want to investigate the logs, because when you get a failed builds, what you don't want to have is a link that goes nowhere, okay? Because unfortunately, this happened for us. Lots of contributors, lots of traffic, and that happens.
For the Google internal build system, we also have these kinds of numbers, but of course with more zeros.
More zeros, yeah.
But we actually throw away test logs.
You throw away?
Yeah, there's too much, especially if you build binaries, they are very large. And
so you will find this talk interesting for you guys as well.
Thank you.
Okay, so there is a problem. So at the beginning, we try to keep more stuff in Jenkins. And the people that will say, look, we have a bigger problem now. That is, gerritci.gerritforge.com doesn't work anymore. I go there and stay waiting forever. Yeah, because Jenkins is not designed to do this stuff well. Because in Jenkins, everything is a file. And Jenkins really needs to access all the time the file, doesn't have an efficient indexing. And then at the end of the day, if your company is not that big, this space is limited. You just have, let's say, look at a node, I remember with 8 terabytes, but we don't have petabytes or even more. Then I asked the community, do we like that? So if you think about logs, are not rubbish. Yeah? Logs are value. Logs is your money. If you're a developer, logs is the money you put in your pocket, is your daily work, analyzing them, crunching them, understanding what they are telling you. The timestamp of the logs are diamonds, are more than gold, are diamonds, because they are telling you if you're making a mistake in your code and maybe a piece of execution of your pipeline is taking more time. Okay, so that's the problem. So the people, that's a real problem. In the mailing list, the people start to say, look, there is a problem with the CI because I got a verification that says that the CI was failing, and then I went there was a 404. They say, no, that's not a bug, that's a feature. How many times you said that, right? There's a feature in Jenkins. This is actually a bug because they don't know how to manage that. Okay, so I asked the mailing list, okay, for how long shall we, because I needed to make a PO for a bigger machine. For how long do you want your logs? 1 day, 1 week, 1 month? And the answer was forever. Yeah, if you think about it, it's true, forever, because maybe now you don't need it, but I don't know, maybe in a month's time I need it to do maybe a different crunch of the same log. Because I don't want broken links if I investigate the reviews, because this is information that gets stored in Gerrit. And you don't want broken links in your Gerrit history, right? Okay, then it was time to me to say, okay, let's think about something, right? And I don't want to spend more time on slideware, so I will show you what I've done. So first of all, I needed to ask Mr. Google for more disk space. But then the second problem was, okay, but then how do I tell Jenkins that he needs to use a different type of storage for the logs? I can't. So I started injecting to the jobs something a little bit strange that is called the Logstash appender. And I will show you what that is. So if we go to a job, let's go, for instance, to this guy. Let's go to the verifier changes. So first of all, we don't manage the configuration manually of the jobs. The configuration of the jobs is in Gerrit code review. But to show you the configuration is much nicer if I show you here on the GUI than just looking at YAML files. But all of these is managed through YAML files and through code reviews. So I installed a plugin that is called Logstash appender, and then I enable for all the jobs. Instead of doing what most of the people do, that is just storing the data without structure into the log files and then getting the log files into Elasticsearch. So this plugin in reality doesn't really store anything, but gets the data in memory attached with the metadata. Metadata means the timestamp, the information about the build, what was the job, what was all the parameters of the job and so on, and sending to an endpoint. An endpoint could be anything. In this case, I've chosen to use RabbitMQ. And not because I like to use RabbitMQ here, because it was not the right tool, but because the guy didn't implement Kafka yet. So I say, in the meantime, we will do RabbitMQ. But very soon, let's say as soon as I modify the plugin and put support for Kafka, there will be for sure Kafka, not RabbitMQ. So basically here, you see that there is a lot of activity here. So you see a lot of message rates. So whenever Jenkins does something, creates some messages on RabbitMQ with the logs attached to the metadata. But then again, I got the same problem. So RabbitMQ is not a storage system. So RabbitMQ is just used as a vehicle then to put stuff to our long-term storage. And then the offer from Dave becomes really interesting. Yeah, now I can put the stuff into Google Cloud Storage. So basically, all the information is going to this queue, is going to this file system directory at this point. The simplest way for me was just create one file every hour. That's it. Yeah. And if you have a look at the files, let's look at this one. They're very, very compressed, and it contains the information that is useful to me. That is, there was a build, there was the ID, it was successful, was not successful, and what is the information. Okay, so problem solved. I can tell all the Gerrit contributors, whenever you have a failure, go and read the JSON file. Maybe not. Yeah, maybe it's not a very nice user experience. So, okay, I can do a little bit more on that. So as company, we contribute to big data projects. We do big data projects. We know Spark. So we say, why don't we do maybe a Spark transformation that gets that information, but then recreates something that is very, very similar to what maybe a developer would expect to see. So there is a Spark job that is crunching this data and is producing something very, very similar to what Jenkins was doing, but in a completely different place, because I don't want Jenkins to see all this rubbish, because Jenkins will get absolutely overloaded. So there is another directory here that actually is not managed by Jenkins, but is generated by these Spark jobs. That is exactly the same structure. It's got verifier bezel, and it's got exactly the same organization of the builds. And look at that. Let's have a look if there is a build 31444 Gerrit verifier here. So if I go here, let's have a look what is the oldest build that I can see here. It's 31639. So for sure, if I go to the build 31444, Jenkins will tell me that doesn't exist. Okay, that's the build 31642. But if I change the same URL and I put a build that Jenkins has completely wiped out, so doesn't exist in Jenkins anymore, look at that, I still see the results. And as I was getting this data from the JSON information, yeah, that contain a lot more, I could, for instance, even render the timestamps, something that Jenkins out of the box doesn't do if you don't install some plugins. And we could, moving forward, do a lot of data crunching as well. So it will be really interesting, for instance, to see what is the correlation between some of the commits in certain branches of Gerrit and what is maybe the trend of the execution time related to certain commits, and provide this feedback to Gerrit. But there will be a lot more that we could do, because the JSON information that I showed you before contains not just the logs, but everything, okay? So that means if we go to this change, so this change was coming from the flow, let's have a look. Okay, that's the change 129953. So it means if I go there, go to this guy, there we go, that was merged. There we go. So you see there is no broken link anymore. So that link that was served by Jenkins, from a user perspective, is still a link from Gerrit. So it's not broken anymore, but it's not served by Jenkins anymore. So it means that as soon as then I follow up with Dave again, instead of putting it to my file system, it will put to the Google file system, I can just point directly to Google. And it means that all the existing changes that I had before, they are still there. And they are not going to be broken anymore. And Jenkins is not going to suffer from them. We are not going to have broken links anymore. And whenever you get a notification from Gerrit CI that says your change works or not, you're not going to get a 404 anymore.
What if I have a Jenkins instance and I want to do this, but I don't have infinite disk space like Google? Is it still possible to?
Okay, yeah. So in terms of infinite disk space, you don't have to go to Google. You can go to AWS as well.
Well,
no, or the other option is to just set up maybe an HDFS yourself. So it means that all those implementation, at the end of the day, they're backed by HDFS. That is an open standard, and it is available as open source as well. So it means that you can store the information there, and you don't have necessarily then to keep it forever. So the community wanted forever. It's fine. But at the end of the day, what you need to keep is for the lifetime maybe of a release or maybe an iteration. So typically people, maybe they keep for 6 months, 12 months. And then as the intermediate files, the one with JSON, typically you organize on a time basis, it's very easy to do the removal or maybe just archiving to a different type of storage or the old ones. So you can say, for instance, I keep only the latest 6 months of data. And another thing, now I showed you archived in JSON, but actually you can use some formats that are much more optimized than JSON. So if you store, for instance, instead of JSON, you store in Avro with a specific encoding that's called Parquet compression. Basically, you can store that information in 1/10 of a size. So you can have even very, very giant big files stored in a very little space. And they're even more optimized when you process them. When you do the dematerialization of the data into the actual files, that process could be even 10 times faster. So in reality, this approach was to aim for keeping the logs forever. But forever means as much as you want. It could be 1 week, 1 month, 6 months. The problem with Jenkins is that sometimes for very busy servers, you can't even keep 1 day of logs. So if the people come the next day to see what's wrong with the change, they find a 404.
So if you were doing the compression and decompression in that way, then would the decompression have to be done server side so that it was transparent to the old URLs that,
Yeah, you can do server side. And there are a lot of ways, for instance, depending on how you organize the information, the decompression can be done on the fly and very, very fast as well. Typically, then there is a talk tomorrow that I'm talking exactly about this problem, how to deal with the crunchy of large amount of data that is coming out of Gerrit. And I'm going to show tomorrow, not here because I don't have time, I want to use space to the next talk. I'm going to show what is called the Lambda architecture, where you define basically a Lambda of space, and you define different level of where you want to store information. In the ones maybe in the last 6 hours, you store in a specific type of storage. But as the time goes on, you want to change the type of storage you do. But definitely the approach is, for us, we want to store forever because we've got Google. But for any other implementation, you store for as much as you want. You're not constrained anymore of the last, I don't know, few hours. That is not enough for developers.
I have implementation question. Does it generate RabbitMQ message for each log statement, or?
Yeah, it's for each log statement. The reason is very simple. If you have, if Jenkins crashes or the build crashes for whatever reason, you don't want to lose that. There was an implementation for the pipeline. It was doing just at the end of the build, and that's wrong because if the build gets aborted, you don't get feedback. So it's for every single line. That's why I said RabbitMQ is not the right way because it's not fast enough. But quite soon the Kafka will come as well.
Okay, because that's what I was going to ask. Did you consider a solution to just upload logs at the end of the task as post action, post build action? And
no, that wouldn't work. Yeah.
Okay.
Yeah.
Thank you.
The Logstash plugin that you mentioned is nothing to have with the Elastic Search Logstash, right? It's just an unfortunate name.
Yeah, just an unfortunate name. Actually, the Logstash plugin was born before the Logstash in Elastic was defined. So Logstash is just a plugin that says, I want to stash the log somewhere. It's nothing to do with the Elastic Logstash, yeah.
And the other question is that you mentioned you do some Spark processing at some point, but it wasn't part of this.
It wasn't part of the demo because I want to leave space to other people, because it would have taken another half an hour. But yeah, it's not complex. It's not complex at all. It's very trivial. Okay.
Yeah, I have a question that's not part of this demo, but it's a Gerrit Forge question. I frequently have tests that fail, or it fails for some reason other than my tests fail, and I want to be able to trigger a rerun of the CI job without having to commit a change just to trigger the CI again. And I was wondering if there is a way that we can maybe make that happen.
Yeah, the URL is this one. And I know you would like a button in Gerrit. It's coming, just running out of time in the organization event here, but the URL is this one. If you go to the Gerrit verifier change here, you run this, you put your change number, you can retrigger the builds without having to commit anything.
And if it passes, it'll get the, okay, cool, I didn't know that.
The URL is that one, but I want to put a button in Gerrit that doesn't require you to go and change the URL.
Yeah, but even that's helpful.
Yep.
Thanks.
Just to follow up on that comment, we make fairly heavy use of topics in Gerrit because we have changes that go across multiple repositories. So we have a very similar job to this one, but we allow people to put in a topic or a change ID or a number of different change IDs, and it works out what the whether that's a consistent declaration. The other thing which, if you've got a moment, you could comment on is you mentioned the verifier job, which runs a number of independent verifications and then feeds back just one result to Gerrit. That sounds like something we could use. What's that built using?
Thank you for the question, because there is exactly tomorrow a presentation about a brand new integration between Gerrit and Jenkins that has been exactly designed by saying, maybe we are not the only one with this problem. So why don't we create a plugin that reuses the experiences we have done in this project and makes it available to all the rest of the world? And that's the talk tomorrow, not today. But yeah, exactly. There will be a plugin that implements that workflow.